Today, once again, welcome to another lesson for physics class. I am on to the year 10 students of Maybest Academy. I want to welcome you to this online class. I hope that we are going to have fun. Now, our topic, we still continue with the topic electrostatics. Remember last class we talked about the definition of electrostatics, the types of charges, ways of producing charges, and the distribution of charges. Now for this class we will only focus on the gold leaf electroscope and the storage of charges. The gold leaf electroscope and the storage of charges. I hope you were able to do my last home fun. Good. So let us go. The gold leaf electroscope. What exactly is the gold leaf electroscope? In general, the gold leaf electroscope is an instrument used for detecting and testing small electric charges. It consists of a flat brass disc or cap and a brass rod with a gold leaf attached to the end of the rod. The brass rod is insulated from the metal case which surrounds the rod and leaf. The case is always halved. That means it's always passed to the ground to prevent accumulation of charges. So let me show you a quick example. Now this is the gold leaf electroscope. This is the flat metal disc insulated from the metal case. I mean, you can see the insulation here. Insulation means that what? There is a material here that does not allow charge to flow from the metal disc to the what? Metal case. Then you can see the gold leaf. The color is amber or yellow to some people. You can see the gold leaf. Then you can see a glass window. The reason why it has a window is to prevent what? Drought or air, as some people call it, interruption of air, so that air does not blow the what? Gold leaf, which might give you what? Error in your reading. Then you have the earth connection. I told you the earth connection is to prevent what? Accumulation of charges. Now, how does the gold leaf electroscope work? How does it work? I believe my next slide should explain better. Now, charging the gold leaf electroscope. Let me go back to the previous slides to quickly give you an illustration of how the gold leaf electroscope works. Now, this is the gold leaf electroscope, but at first it is uncharged. So you first must charge the gold leaf electroscope, either by bringing a body close to it or by touching it. So when you bring a body close to the metal disc, the gold leaf or the metal disc acquires a charge, either positive or negative. Now this charge, because the disc is metallic and you know that metals are good conductors, this cap transfers the charge to the what? To the brass leaf that you have here, to the brass leaf. You can see the metal plate here. And the brass leaf and the gold leaf, they have what? The same charge. Now, if they have the same charge, what do you think will happen between the brass or the metal plate and the gold leaf? If they have the same charge, from the law of electrostatics, they will move away from each other. They will open up. They will diverge. That is how it works. That is how the gold leaf electroscope works. So let us talk about how to charge the gold leaf electroscope. Remember last class we talked about 3 ways of charging a body: by friction, by contact, and by electrostatic induction. So there are 2 ways by which you can charge the gold leaf electroscope: by contact and by what? Electrostatic induction. By contact means you are touching the charged body with the what? With the electroscope. You can see that the charged body is negatively charged and it is touched. You can see that it meets the what? Gold leaf electroscope. It is touched with the what? Gold leaf electroscope. And what happens? The metal disc acquires what? Negative charge. And this negative charge is transferred to the what? Gold plate. Is transferred to the what? To the gold plate and the what? Metal plate. Now because they are what? Similar charges, they what? Repel. Look at it here. The gold leaf is not charged. Now once it becomes charged and they have similar charge, they what? Open up. That is, they diverge. That is charging an electroscope by contact. Now by induction, electrostatic induction, I told you from last class that you just bring the charge body very close to it without touching the electroscope. Now you can see that there's actually a space between the charge body and the what? Metal disc. Now what do you notice? The charge body is negatively charged while the metal plate becomes what? Positively charged. That is, for electrostatic induction they acquire opposite charges, while for charging by contact they acquire the same charge. So if you want to charge the body by electrostatic induction and you bring a negatively charged body, the gold leaf becomes what? Positively charged. Then this positive charge is transferred downwards. That means the metal plate becomes positively charged, and also the what? Gold leaf becomes positively charged. And what happens there? They open up, they diverge. So it is safe to say that divergence, or the degree of divergence, is the only way by which you can test for a charge for a gold leaf electroscope. Now moving on to our next slide, using the gold leaf electroscope to detect charge. How can you use the gold leaf electroscope to detect charge? Divergence of the gold leaf electroscope is the only way to test for a charge using an electroscope. An increase in divergence indicates that the charge on the electroscope and that of the test charge are the same. The magnitude of the charge is also measured by the degree of divergence of the leaf. This is what I explained previously, that divergence is the only way by which you can test for what? A charge. Let's say a body is what? These are what? Positively charged. These are positively charged, and you bring a negative material to it. What happens to the level of divergence? It what? Collapses. It decreases. Why? Because positive and negative, they what? Attract. But if you bring a positive charge to this body again, that means the level of divergence will increase. And the only way to test for charge is by what? By the divergence. Now if the charge here is more, if the charge that you bring here is more, then that means the divergence will be more. But if there's a reduction in the what? Charge that you bring close, that means the divergence will reduce a little. Now moving on to storage of charges. How can we store charges? Now there are two instruments in science that you can use to store what? Charges. The first one is an electrophorus. And it is a device used for transferring and storing charge. The electrophorus does not store charge alone, it also what? Transfers charge from one place to another. While the second one is a capacitor. This is what we'll be considering when we move on to the what? Next topic. A capacitor is also a device used for storing electric charge. So I have something here for you, something you are going to do and send to the comment section or to the HOS Academy, please. It is very important you do them. Now in the first column, you can see the charge on electroscope. The second column, you can see charge brought near the cap. The third one, you can see the effect on leaf. I have filled some box for you. You just need to what? Fill the others. Now the charge on the electroscope is positive. The charge brought near the cap is positive. What happens to the divergence or to the effect of the leaf? Of course, positive from the law of electrostatics, it's what? Repel each other. So the divergence increases. So you have to fill in the box and what? Drop them at the comment section of the video. Thank you. Have a wonderful time.